Alright, we're working on Trig Review 2 worksheet for the Trig test, and this is question number 12. A student wants to measure the height of a flagpole using a clinometer. She determines that while standing 1,284 inches from the pole, the angle made from her eyes to the top of the pole is 39 degrees. The distance from the ground to her eyes is 56 inches. What is the height of the flagpole? Well, the good news is the drawing is already made, and we already have all of our measurements labeled here, and we've done this in class, so you know how to do this in actual real life. Let's go ahead and figure out that we're going to have to first find the length of AB because we're trying to find the height of the flagpole. So we're going to try to find the length of AB first, and this is going to require trigonometry. So same rules apply as always. Trigonometry, we're going to write SOHCAHTOA, and AB is the hypotenuse, and if 39 is our reference angle, that means that this side is opposite and BC is adjacent. And you can see, class, we're going to make this a little bit quicker. If we have a reference angle of 39, we know adjacent, we want to know opposite, that means we're going to use tangent. So our equation is going to be tangent of our reference angle, which is 39 degrees, is equal to opposite, because tangent is opposite over adjacent. Opposite is what I don't know. Adjacent is what I know. So this is an x on top situation. So we're going to make this a multiplication problem, since if we multiply both sides by 1,284, we're going to get x by itself. So x is equal to 1,284 times tangent of 39. I hope you guys are realizing at this point with trigonometry, the math itself is not a difficult thing to do, but getting the fraction, getting the right value on top and bottom, and then making sure you understand how to handle an x on top situation and an x on bottom situation. You'll lose a lot of points in the test if you try to set this up, but you get things flipped around. So just be careful about how you label opposite and adjacent and hypotenuse and how you set up your trig equation. If we plug this into our calculator, we're going to get x is approximately 1,039.8, and that's going to be inches. And then we got to be careful because it says, what is the height of the flagpole? What is the height of the flagpole? Well, students, we just figured out what AB was. That tells us the distance from here to here. But we have to add in this part as well because that wasn't measured or wasn't calculated in our length of AB. And that is going to be the distance from the ground to the person's eyes. So to find the actual height of the flagpole, we're going to have to add AB to CD. And AB is 1,039.8. CD was 56. And so the height of the flagpole is actually approximately 1,095.8. Now again, I'm going to say this to you guys. I need you to write a sentence answer. So I'm going to put this here for those of you who are just checking your answers. Sentence answer. That means if you want credit on this worksheet, you're going to have to write something like the height of the flagpole is 1,095.8 inches. 1,095, or approximately 1,095.8 inches. So make sure you write it as a sentence answer. Alright, next one, number 13. A ship uses sonar to find the location of an enemy submarine. What is the horizontal, or H, that's this side right here, what is the value of H, or horizontal distance, and vertical distance, or D? The reason we use D is because that's the depth. And H stands for horizontal distance. I could have used V there, but D, the vertical distance to the submarine. Well, we got two calculations here. Let's do them both. So on one side of the page, I'm going to go ahead and set this up, and let's find, I don't know, let's do H first. So we're going to find H. And that means over here we're going to find D. Alright, well, our reference angle is 34. This is the hypotenuse, the side that doesn't touch the right angle. If our reference angle is 34, then H is adjacent and D is opposite. So if we're going to find H, let's write SOHCAHTOA. I'll put that right here. I'm going to do this again. I'm going to shortcut this a little bit. Actually, you know what? I'm going to write this all out. Okay, our reference angle is 34. We know the hypotenuse. We want to know H, which is adjacent. So in this case, we want to do adjacent and hypotenuse, and that is cosine. So our equation is going to be cosine of reference angle 34 is equal to adjacent. So adjacent is our unknown side over hypotenuse, which is 820. Notice, class, I've been skipping some steps now as I get better at this. I don't have to write cosine of some angle letter is equal to adjacent over hypotenuse. I just am going back and making sure I'm putting my right numbers in. So don't flip these around. Make sure you realize cosine is adjacent. Adjacent is my unknown side for H over hypotenuse, which is my known side. This is an x on top situation, which means it's going to be multiplication. X is equal to 820 times cosine of 34, and that's going to be approximately 679.8, and that's going to be meters. So your final answer here could be in a sentence, or I'd be okay if you wrote on here H is approximately 679.8 meters. Excuse me. Okay, let's find D. Same steps. SOHCAHTOA. Our reference angle here is still 34. What do I know? It's still the hypotenuse, but now the side I want to know is D. I'm looking for D. That is opposite. So now I've got opposite and hypotenuse. That's going to be sine. So now we use sine. Sine of our reference angle is equal to opposite over hypotenuse. Opposite is D. We don't know that. Our hypotenuse is 820. Again, this is a multiplication problem since x is on top. So x is equal to 820 times sine of 34, and that's going to be approximately 458.5. So again, you could write the depth is approximately, or vertical distance is approximately, or I'd be okay with this as well. D is approximately 458.5 meters. Okay, question number 14. Now we're going to look at the height of a building, or sorry, the distance away from a building. From his current position, the student wants to calculate how far away a building is. Using a clinometer, he determines that the angle made from his eyes to the base of the building is 81 degrees. That's already labeled for us. The distance from the ground to his eyes is 59 inches. Using Trig, find the distance to the building, which is AB. Well, let's label how we're going to set this up. We're looking for a missing side, so we're using Trig. There's our reference angle. That's hypotenuse. AB is opposite, and the height from the ground to our eyes is adjacent to 81. And we want to find AB. So we're going to write SOHCAHTOA. Okay, our reference angle is 81. We know adjacent to our reference angle, not hypotenuse, and we're looking for opposite. We know adjacent, and we want to know the distance from where we're standing to the building. AB, we want to know how far it is on the ground. So we want to know opposite. And opposite and adjacent is tangent. So that means our equation is going to be tangent of our reference angle 81 is equal to opposite over adjacent. Opposite is our unknown. Adjacent is the height of our eyes. This is an x on top. That means it's going to be a multiplication problem. 59 times tangent of 81. And that's going to be approximately 372.5. So you should write this as a sentence answer. So I'm going to give this to you something like this. The distance to the building is approximately 372.5, and this is all in inches. So I'll put inches here. So if you would again write this as a sentence answer. The distance, or the approximate distance to the building, is 372.5 inches. All right. We've got one more problem, question number 15, and that will wrap up our trig review. A forestry worker needs to determine the width of a river. She stands on one side of the river and identifies a tree growing on the opposite shoreline and places a marker at her position. This is marker number 1. So here's where the forestry worker is standing. She's standing right here at marker number 1, and she sees a tree across the river. Okay, so next she walks left along the riverbank, perpendicular. I want you guys to see this. Perpendicular means at a right angle. So at a right angle, let me darken that a little bit. At a right angle. So she's going to walk. Let's do this. I'm going to have her walk along the river. So let's get that about perpendicular the best I can. Alright. So there she is walking left to the left along the river. And let's go ahead, you know what, let's mark this as well. Actually, you know what, I wanted to make that orange. Let's make this one green. Let's just say this is what we're looking for. When it said perpendicular, then you know what, let's go ahead and mark this as a right angle. So this is a right angle from the marker to the tree and then walking along the river. She marks this location and finds that the distance between the two markers is 122 feet. So she's going to walk until she makes a 60-degree angle between her original marker and the tree. Original marker and the tree. You know what? Let's check that wording. She walks left along the riverbank perpendicular to her original marker until she makes a 60-degree angle between her original marker and the tree. Okay, got it. So if we're looking at this, let's go ahead and make another line here. I'm going to go ahead and say this is going to make a triangle right here. And that means that she is making a 60-degree angle right here between the original marker and the tree, and this is her marker number 2. So if I want to just put M2 for marker number 2. Okay, what is the width of the river at the first marker? So they're asking us what's the width of the river. They want us to tell them what is this length of this side right here, which is really the distance across the river from her first marker to the tree across the river. Now class, I can tell you right now, you can use trig to solve this problem, but I'm going to do a little bit faster because in this situation, we got a 60-degree angle and a 90-degree angle. This is a 30, 60, 90 triangle. I can use the properties of 30, 60, 90 triangles to actually find this missing side. Again, trig can also be used as well, but let's use 30, 60, 90. So I'm going to go ahead and sketch out a 30, 60, 90 triangle. See if I can do that here. So here is my 30, 60, 90 triangle. Let's label that. So I've got a right angle here. And you know what? I'm gonna flip this around. Hang on a sec. I want it to match my drawing. Let's see if I can rotate that. There we go. Now it's going to match my original drawing. And I'm going to stretch it out a little bit to make it look a little bit more like that. Alright, that's a little bit better. Okay, so now again we've got our right angle right here. We know this is 60 degrees. And this is going to be our hypotenuse. This is going to be our long leg. This is going to be our short leg. And we know the properties of special triangles. 30, 60, 90 tells us the short leg is x. The long leg is x times the square root of 3. And the hypotenuse is 2x. Well, which side do we know? It says the distance between the two markers is 122 feet. So we know this is 122 feet. Well, that means we know that this side is 122 feet. Sorry, let's label that a little bit off. This is 122 feet. Well, there's the side we're given. We're given the short leg. The key to this one, class, is recognizing which is the short leg and which is the long leg. Remember, the side that is adjacent, the leg that's adjacent to the 60-degree angle is the short leg, and the one that's across from the 60-degree angle or opposite is the long leg. So now let's just go ahead and use our properties of 30, 60, 90 triangles. We are already told that x is equal to 122 feet. The side we want to know is the long leg right here, and we know that is equal to x times the square root of 3. So that means our long leg is just 122 times the square root of 3. 122 times the square root of 3 is approximately 211.3. So 211.3, and we're looking at feet. So my answer would be is the distance, the width of the river at the first marker is approximately 211.3 feet. Now, if you want to use trigonometry for this problem, you can use trig as well. Let's take a look at how you would do that. It's pretty simple. I'll just look at the triangle right here. We've got SOHCAHTOA, our reference angle is going to be 60 degrees. We know the side that's adjacent to the 60-degree angle. We want to know the side that is opposite. Opposite and adjacent is tangent. Our equation is going to be tangent of 60 is equal to opposite, which is the one we don't know, over adjacent, which is the one we do know, 122. This is a multiplication problem, so x is equal to 122 times tangent of 60 degrees. And if you put that in your calculator, you're going to get approximately 211.3 feet. So you're going to see either way, trig or special triangle will do the job and get us the same answer. Again, you should write this as a complete sentence. The width of the river at the first marker is approximately 211.3 feet.